Mahesh, start.
Good morning to everyone. We are from Sri Jignasa Memorial Government Degree College, Narayanpet district. Today we all know about Jignasa Student Study Project from 2024 to 2025. These are my colleagues are Indi Shedbek, J. Bhavani, K. Sweta, M. Chaitra, K. Varun Reddy. And our mentors and co-mentors are Rangareddy sir and Krishna Reddy sir and also Sureka ma'am. This is a content of our mathematics project. And first one is introduction, objective. These are the discussion, summary and conclusion, and also references. This is the role of derivatives in daily life. And also objectives of our mathematics project. Explaining the knowledge of differential equations in differential field, and also uses of the differential equations in physics, and to solve the problems and methods of theory. And also differential equations in statistical methods. Differential equations play and change the important role in various fields, not only in education but also in medicine, economics, and investigational fields. By knowing the relation between variables, that are independent variables and dependent variables, by connecting equations using the arbitrary constants and forming the differential equation and calculating the rate of change between a variable based on the independent variable. The next part will be continued by co-mate Bhavani.
Good morning to everyone. Now I am going to explain about what is differential equation. In terms of mathematics, the differential equation is the relationship that involves the derivatives of a function or a dependent variable with respect to an independent variable. It is represented as dy by dx equal to f of x equal to y dash, where x is independent variable and y is dependent variable. There are so many applications of differential equations in mathematics based on first order differential equation and partial differential equation. First order differential equation. A differential equation involving ordinary derivatives of one or more dependent variable with respect to a single independent variable and which has only one order derivatives is called first order differential equation. There are various types of differential equations. First one is ordinary differential equation and second one is partial differential equation. Now if a differential equation which contains only one independent variable is called as ordinary differential equation. If it involves two or more independent variables is called partial differential equation. For example, dou square a by dou s dou t equal to s square t plus st square. Nowadays, partial differential equation create many wonders in so many fields. Next part will be continued by Shweta.
Now I am discuss about applications of differential equation. There are a lot of applications of differential equation in our real life in various sectors. Cooling, volume law, Newton's law of cooling, population growth and decay, mixture of two solutions and tumor growth, and economics in finance. Next, models of the population growth. One model for the growth of the population is based on the assumption that the population grows. Next, this is the example of the population growth and decay. A population growth at the rate of 5% per year. How long does it take for the population to double? This is the solution of the given example. And final result is the population is double in 14 years. Next part will continue by Chaitra.
Good morning to everyone. One of the most important applications of differential equations are used in Newton's law of cooling. Newton's law of cooling states that the rate which an object cooled down is directly proportional to the difference in temperature between the object and object surroundings. But the temperature of the surroundings must remain constant during the cooling of the body. Mathematically, it is represented as dq by dt is proportional to T0 minus Ts. Also, dq by dt is equals to minus k into T0 minus Ts. Here, dq by dt is equals to change in temperature of the object with respect to time. T0 equals to temperature of an object, Ts equals to temperature of the object surrounding, K equals to proportionality constant. But the temperature of the object depends on temperature of the object surrounding. So for body of mass m specific heat is and it is kept in temperature of the surrounding Ts there. It is a derivation. Next part will be continued by Varun Reddy.
The continuation of Newton's law of cooling. The Newton's law of cooling is used by the forensic department. Let's take an example of a death case to find the time of death of a victim. An investigator is called to the crime scene X hours after the death. The temperature is found 27.4 degrees Celsius. And 1 hour later, the temperature is found 26.1 degrees Celsius. And we know the constants. The temperature of surrounding Ts is equals to 21 degrees Celsius and the initial temperature T0 is equal to 36.8 degrees Celsius. By using the formula of Newton's law of cooling, T of T, we can find the time of death. For our example, the time of death is 3.9 hours ago. The victim was dead 3.9 hours ago. And we can see the graph that temperature is gradually decreasing according to the time. That's the Newton's law of cooling. Yeah. We are concluding our presentation by saying that for any nation development, there are two factors, education and health. Nowadays, health maintenance is very important because of the threats of virus we are facing in our life. The causing and the treatment of death is an independent variable, and the spreading of virus is a dependent variable. If you form the equation and differential equations of the viruses, we can easily estimate the rate of spreading. By rate of spreading, we can take precautions and we can reduce and stop the virus or any diseases. Yeah, that's our presentation. Thank you.